Hello guys, welcome to another video. Today I'll show you how we made a mini tethered quadcopter for a workshop on drones. Do keep in mind that this is a tethered drone without any control circuits or inbuilt power. And if you want to modify or add control to this drone, it's possible by adding required components, as it was fully capable of lifting some decent payload in the tests. So without further ado, let's get started. First of all, this is a Mini-Quadcopter, so we chose these small coreless DC motors with their respective propellers. Keep note that the propellers needs to be in pairs of clockwise and counterclockwise. Next, we made the airframe for the quadcopter. This was the frame that I built. I used PVC section in the middle so that the drone can be slid on a guide rod. The arms are made out of bamboo sticks. The motors are fixed to the airframe quadcopter using thread and super glue. The motors are wired according to its correct polarity and in parallel. It's connected in parallel to ensure that each motor draws equal current and voltage. The motor configuration of the quadcopter is this. In each of the arms, the motors spin clockwise and counterclockwise alternatively. This helps to cancel out the net torque produced by the motors. This is the guide rod where the drone is flown, and this is the RPS we use to power the drone. I set the RPS to 3.7 volts, which is the operating voltage for the motor. The motor might produce a combined current draw of around 2 amps. Then each motor consumes around 500 milliamps. A stopper is placed on top of the guide rod to limit the travel of the drone. This is the wires that I use for powering the drone. It's a thin single core cable, and the switch is used to switch the power on and off. As you can see, as soon as the power is turned on, the drone goes up quickly. This is because when the power is turned on, it's set to 3.7 volts, which equals to 100% of the thrust. The drone now consumes around 1.7 amps. The drone is not set to load right now. The drone is more than capable of supporting a control circuit and a battery, in my opinion. The drone can be controlled by varying the input voltage applied to the motors. Thus, applying different voltages using a control circuit will aid in a stabilized flight. The power to weight ratio is really good in this drone. This drone was able to lift itself only using 2 motors. But the motors did consume a bit more voltage this time to compensate for the power. As our quadcopter prototype was successful in flying and was simple for younger students to understand, we were tasked to make more quadcopters that can be easily assembled and flown. This was the final design that we concluded. All parts were made out of corrugated plastic, and was assembled using superglue and cable ties. Holes with the diameter of the motors were pre-cut into the drone body to aid in assembly. The motor is fixed in place using cable ties. After the propellers were fixed and the wires properly connected, the drones were ready to fly. The drone workshop was conducted by a group of teachers and students, where basics of drone application and their construction methods were taught. A live interactive session was also given by a miniature quadcopter, and at the end the students were taught on basic drone making using a hands-on approach, and they were successful at building their own drones. At last, each of the drones were tested for their ability to fly, and the workshop was concluded. Okay friends, thank you for watching. Please like and smash that subscribe button if you liked the video. Goodbye.